Do you want to enjoy amazing space pictures every time you browse the internet? You can use the free ESA/Hubble Chrome application, which is available as an extension on the Chrome Web Store. Once installed, you will be shown an image from the ESA/Hubble Top 100 Images collection in each new open tab. Just like this one here, showing part of the sky in the constellation of Orion, the Hunter. Image credit: NASA National Aeronautics and Space Administration/ESA European Space Agency, and the Hubble Heritage Team, ORA/STSCI. Are you ready for a spooky picture? Our Halloween Hubble image shows Able 611, a popular target for investigating one of the most mysterious and elusive quantities in the universe, dark matter. All galaxy clusters, the continued existence of Able 611 poses a mystery to astronomers. Specifically, there does not appear to be enough mass contained within its web of rapidly rotating constituent galaxies to prevent the cluster from flying apart. The leading theory to explain why galaxies like Able 611 remain intact is that the universe contains vast amounts of a substance known as dark matter. Whilst the name might sound ominous, dark simply refers to the fact that this unknown quantity does not seem to interact with light as other matter does, neither emitting nor reflecting nor absorbing any part of the electromagnetic spectrum. Galaxy clusters such as Able 611 are good laboratories for investigating dark matter, owing to gravitational lensing visible within the cluster. An example of lensing is perhaps most clearly visible in the center of the image, to the left of the cluster's bright core, where a curve of light can be seen. This curve is light from a more distant source that distorted by Able 611's mass. Even whilst the mystery of what holds the cosmic cobweb of galaxies within Able 611 together remains unsolved, we can still enjoy this image and the fascinating science, both well established and theorized, taking place within it. Read more: ESA European Space Agency/Hubble Space Telescope/NASA National Aeronautics and Space Administration, P. Kelly, M. Postman, J. Richard, S. Allen. Feel the universe at your fingertips and access a universe of knowledge with the ESA/Hubble Top 100 Images Chrome extension. The 100 most astonishing astronomy images from the Hubble Space Telescope are selected at random when you open a new tab. The lives of newborn stars are tempestuous, as shown by this new Hubble image of the Herbig Haro objects HH1 and HH2 that lie in the Orion Nebula. Herbig Haro objects are glowing clumps found around some newborn stars, and are created when jets of gas thrown outwards from these young stars collide with surrounding gas and dust at incredibly high speeds. Hubble observations in 2002 have shown that parts of HH1 are moving at more than 400 kilometers per second. The young star system responsible for the creation of HH1 and HH2 is lurking out of sight. However, an outflow of gas from one of these stars can be seen streaming out from the central dark cloud as a bright jet. Read more: ESA European Space Agency/Hubble Space Telescope/NASA National Aeronautics and Space Administration, B. Riper, B. Nassini. While appearing as a delicate and light veil draped across the sky, this actually depicts a small section of the Cygnus supernova blast wave, located around 2,400 light-years away. The name of the supernova remnant comes from its position in the northern constellation of Cygnus, the Swan, where it covers an area 36 times larger than the full moon. Read more: image credit: ESA European Space Agency/Hubble Space Telescope/NASA National Aeronautics and Space Administration/W. Blair. Hubble Space Telescope. 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 This picture of the week shows an enigmatic explosion, a bright young star shrouded by gas and dust. Known to astronomers as IRAS 05506+2414, this object is thought to be an example of an explosive event caused by the disruption of a massive young star system. Usually the swirling disks of material surrounding a young star are funneled into twin outflows of gas and dust from the star. In the case of IRIS 05506 plus 2414, however, a fan-like spray of material traveling at velocities of up to 350 km per second is spreading outwards from the center of this image. Astronomers are using Hubble to determine how bright the young star is and how much energy it is emitting, and hence to estimate its mass. This will help to understand the origin of this bright young star's unusual outflow. Read more. ESA European Space Agency / Hubble Space Telescope and NASA National Aeronautics and Space Administration are Cepheid. A FREGG explosion of star formation. This image depicts a special class of star-forming nursery known as free-floating evaporating gaseous globules, or FREGGs for short. This object is formally known as J025157.5 plus 600606. Read more. Image credit. ESA European Space Agency / Hubble Space Telescope / NASA National Aeronautics. Astronomers using Hubble Space Telescope have discovered young stars spiraling into the center of a massive cluster of stars in the Small Magellanic Cloud, a satellite galaxy of the Milky Way. The outer arm of the spiral in this huge, oddly shaped stellar nursery, called NGC 346, may be feeding star formation in a river-like motion of gas and stars. The discovery sheds new light on the process of stellar birth. Full story details the Small Magellanic Cloud is similar to the galaxies found in the younger universe, with a simpler chemical composition than the Milky Way and with fewer heavier elements. This means stars in the Small Magellanic Cloud burn hotter and run out of their fuel faster than in our Milky Way. Learning how stars form in the Small Magellanic Cloud offers a new twist on how star birth may have occurred early in the history of the universe, when it was undergoing a baby boom about 2 to 3 billion years after the Big Bang. The universe is now 13.8 billion years old. NGC 340 SIX's intriguing shape and rapid star formation rate have puzzled astronomers. It took the combined power of the Hubble Space Telescope and at ESO Astronomy's Very Large Telescope, VLT, to unravel the mysteries of this stellar nesting ground. These precise observations were only possible because of Hubble's high resolution and sensitivity. Its long history of observations allows astronomers to follow minute celestial motions over time. The new results show that the process of star formation there is similar to that in our own Milky Way. Image credit. NASA National Aeronautics and Space Administration ESA European Space Agency. Stars are coming to life in this depicting a fantastic new class of star-forming nursery, known as free-floating evaporating gaseous globules, or FREGGs for short. This object, known as J025027.7 plus 600849, is located in the constellation of Cassiopeia. Read more. Image credit. ESA European Space Agency / Hubble Space Telescope / NASA National Aeronautics and Space Administration are Cepheid. This celestial clouscape featured in our latest picture of the week captures the colorful region surrounding the Herbig-Haro object HH505. Herbig-Haro objects are luminous regions surrounding newborn stars, and are formed when stellar winds or jets of gas spewing from these newborn stars form shockwaves colliding with nearby gas and dust at high speeds. In the case of HH505, these outflows originate from the star 9 Ori, which lies on the outskirts of the Orion Nebula around 1,000 light-years from Earth. The outflows themselves are visible as gracefully curving structures at the top and bottom of this image, and are distorted into sinuous curves by their interaction with the large-scale flow of gas and dust from the core of the Orion Nebula. Read more. Image credit. ESA European Space Agency / Hubble Space Telescope / NASA, J. Valley Acknowledgement, M.H. Ozark. This stunning features the spiral galaxy NGC 5643 in the constellation of Lupus, the Wolf. Looking this good isn't easy. 30 different exposures, for a total of 9 hours observation time, together with the high resolution and clarity of Hubble, were needed to produce an image of such high level of detail and of beauty. Read more. Image credit. ESA European Space Agency / Hubble Space Telescope / NASA National Aeronautics and Space Administration, A. Rees et al. Do you want to enjoy amazing space pictures every time you browse the internet? You can use the free ESA/Hubble Chrome application, which is available as an extension on the Chrome Web Store. Once installed, the user will be shown an image from the ESA/Hubble Top 100 Images collection in each new open tab. Just like this one here, showing part of the sky in the constellation of Orion, the Hunter. Image credit, NASA National Aeronautics and Space Administration/ESA European Space Agency, and the Hubble Heritage Team, ORA/STSCI. This luminescent picture of the week features multiple galaxies, perhaps most noticeably Leda 58109, the lone galaxy in the upper right. Leda 58109 is flanked by two further galactic objects to its lower left, an active galactic nucleus, AGN, called SDSS-J162558.14 plus 435746.4 that partially obscures the galaxy SDSS-J162557.25 plus 435743.5, which appears to poke out to the right behind the AGN. Read more. Image credit, ESA European Space Agency/Hubble Space Telescope/ On July 12, the first full-color images and spectroscopic data from James Webb Space Telescope will be released. Will help astronomers study the early universe, the evolution of galaxies, and the atmospheres of exoplanets, complementing Hubble's observations. Now, 6 months after its launch, Webb is ready to start observing. Institutions all over Europe were invited by ESA European Space Agency to help us celebrate as full-color images for the first time. The community is organizing events all over Europe which you can join in. Check out the full list of organizers here, with more details about the events to follow as we get closer to the date. Cosmic Intruder Alert. Can you spot this asteroid trail in the Crab Nebula, M1? This asteroid, from the main belt, is known as 2001 SE101 and was spotted by a citizen scientist. Credit, ESA European Space Agency/Hubble Space Telescope, M. Thevenot, at Astronomy. On June 30th, marks the anniversary of the largest observed asteroid strike in recorded history, the asteroid that exploded over Tunguska in Siberia in 1908. Estimated to have been 40 m in diameter, the asteroid felled 60 million trees and impacted an area the size of a major metropolitan city. Nowadays, scientists are prepared to predict such asteroid events, and missions such as ESA European Space Agency (HERA), planned for 2024, are being developed to deflect asteroids and improve humanity's planetary defense. If you want to learn more about asteroids, make sure to see our entry. If you read our entry about white dwarf, answer this: what is the temperature of a white dwarf? Extremely hot, cold as ice, warm as earth? Leave your answer in the comments. Looking like glittering jewels, the stars in this Hubble Space Telescope image at left are part of the ancient globular star cluster NGC 6397. Scattered among these brilliant stars are extremely faint stars. The advanced camera found the faintest red dwarf stars, 26th magnitude, which are cooler and much lower in mass than our Sun, and the dimmest white dwarfs, 28th magnitude, the burned-out relics of normal stars. The light from the dimmest white dwarfs is equal to the light produced by a birthday candle on the Moon as seen from Earth. The image at lower right shows the faintest red dwarf star, the red dot within the red circle, spied by Hubble. Learn more about what white dwarfs are and Hubble's observations from our credit, ESA European Space Agency/NASA National Aeronautics and Space Administration/H. Richer, University of British Columbia. If you read our entry about supernova, answer this: after a supermassive star has begun to die, it forms a red supergiant white dwarf nebula. Leave your answer in the comments. Here is the answer to the challenge. Only 2 days left to submit the event proposals for NASA/ESA/CSA James Space Telescope Early Release Observations, ERO. Get creative and send us your ideas for the special events. Illustration: ESA European Space Agency/ATG Media Lab. Test your Sherlock Holmes abilities on our latest picture of the week. Just like the magnifying glass of the great detective, the NASA/ESA Hubble Space Telescope has been used to peer into an astronomical mystery in search of clues. In this picture of the week, the enigma in question concerns the globular cluster Ruprecht 106, which is pictured in this image. While the constituent stars of globular clusters all formed at approximately the same location and time, it turns out that almost all globular clusters contain groups of stars with distinct chemical compositions. These distinct chemical fingerprints are left by groups of stars with very slightly different ages or compositions from the rest of the cluster. A tiny handful of globular clusters do not possess these multiple populations of stars, and Ruprecht 106 is a member of this enigmatic group. Read more. Here is your detective challenge. In this image, some bright spots are stars and some are galaxies. There is one particular elliptical galaxy, close to the center of the cluster, that looks orange and does not have spikes. Can you find it? We'll post the answer later. Image credit: ESA, European Space Agency / Hubble Space Telescope / NASA, National Aeronautics and Space Administration, A. Daughter. If you read our entry about stars, answer this: M-type stars are the coolest and the reddest, the hottest and the bluest, the whitest. Leave your answer in the comments. This is one of the brightest stars seen in our galaxy. The giant star A.G. Carinae is surrounded by an expanding shell of gas and dust. The nebula is about 5 light-years wide, which equals the distance from here to our nearest star, Alpha Centauri. Learn more about stars and Hubble's observations from our credit: NASA, National Aeronautics and Space Administration / ESA, European Space Agency and Space Telescope Science Institute. Hubble helps explain why Uranus and Neptune are different colors. Using observations from the NASA / ESA Hubble Space Telescope, as well as Gemini Observatory and the NASA Infrared Telescope Facility, researchers have developed a single atmospheric model that matches observations of both planets. Full story details: the model reveals that excess haze on Uranus builds up in the planet's stagnant, sluggish atmosphere and makes it appear a lighter tone than Neptune. Neptune and Uranus have much in common: similar masses, sizes, and atmospheric compositions, yet their appearances are notably different. Astronomers now have an explanation for why the two planets are different colors. New research suggests that a layer of concentrated haze that is present on both planets is thicker on Uranus than on Neptune and therefore whitens Uranus's appearance more than Neptune's. In its absence, both would appear almost equally blue. This is the first model to simultaneously fit observations of reflected sunlight from ultraviolet to near-infrared wavelengths, said lead author Patrick Irwin, professor of planetary physics at University of Oxford. The team's model consists of 3 layers of aerosols at different heights. The key layer that affects the colors is the middle layer, which is a layer of haze particles that is thicker on Uranus than on Neptune. To create this model, Irwin's team analyzed archival data spanning several years from Hubble credit, NASA, National Aeronautics and Space Administration / ESA, European Space Agency, A. Simon, NASA's Goddard Space Flight Center, and M.H. Wang, UC Berkeley, and the Opal team. If you read our entry about the spiral galaxy, answer this: in contrast to elliptical galaxies, spiral galaxies are populated by stars that are on average much older, much younger, bigger. Leave your answer in the comments. The muted red tones of the globular cluster Liller 1 are partially obscured by a dense scattering of piercingly blue stars in our latest picture of the week. In fact, it is thanks to Hubble's Wide Field Camera 3, WFC3, that we are able to see Liller 1 so clearly in this image, because the WFC3 is sensitive to wavelengths of light that the human eye cannot detect. Read more. Image credit: ESA, European Space Agency / Hubble Space Telescope / NASA, National Aeronautics and Space Administration, F. Ferraro. In honor of International Day of Light, May 16th, we dedicated this entire week to Hubble's use of spectroscopy. Let's have a short recap of how spectroscopy works. Any object that absorbs or emits light can be studied with a spectrograph to determine characteristics such as its temperature, density, chemical composition, and velocity. Once the light enters the spectrograph, it is split by a dispersive optical element into its different components, or wavelengths, in order to be studied. This element acts much like rain droplets that disperse the light to form a rainbow. This dispersed light is then focused onto a detector and it is seen as a spectrum. The spectrum's pattern can be analyzed by astronomers to decipher what atoms and molecules are present in the source. This helps them to understand the various physical and chemical characteristics of the source. In this way, Hubble's images tell us what something looks like, while the spectrum data tell us what it is and what it's made of. Don't forget to check our for a deeper dive in the topic. Image credit, NASA National Aeronautics and Space Administration / ESA European Space Agency. Hubble brings you a dazzling collection of supernova host galaxies. Spanning from 2003 to 2021, this collection of 37 images from the NASA / ESA Hubble Space Telescope features galaxies that are all hosts to both Cepheid variables and supernovae. Full story details these two celestial phenomena are both crucial tools used by astronomers to determine astronomical distance, and have been used to refine our measurement of Hubble's constant, the expansion rate of the universe. Each of the 37 images in this special collection features a spiral galaxy that hosts both Cepheid variables and a special class of supernovae, two remarkable stellar phenomena that on the face of it do not have much in common. Cepheid variables are pulsating stars that regularly brighten and dim, and type Ia supernovae are the catastrophic explosions that mark the death throes of a hot, dense white dwarf star. However, both can be used by astronomers to measure the distance to an astronomical object. Even before it was launched, one of Hubble's main science goals was to observe Cepheid variables and supernovae. These observations can help measure the expansion rate of the universe, a value which astronomers call the Hubble constant. Generations of astronomers have refined this value over almost 30 years using data from more than 1,000 hours of Hubble time. Interestingly, the expansion rate determined from observational data from telescopes is significantly different from the value predicted by our current standard cosmological model of the universe. The richness of the Hubble data means that this is vanishingly unlikely to have happened by a chance selection of misleading observations. Image credit, NASA National Aeronautics and Space Administration / ESA European Space Agency. Spectroscopy was the foundation of many key Hubble discoveries. For example, Hubble recorded a black hole signature, and its spectroscopic observations fingerprinted the distant universe using the light from quasars to allow astronomers to probe the raw materials from which galaxies form. Using its spectrographs, Hubble also provided the first direct detection of the atmosphere of a planet orbiting a star outside our solar system and detected organic molecules in the atmosphere of a planet orbiting another star. Keep celebrating with us International Day of Light May 16th. Learn more spectrographs and spectroscopy and how Hubble uses them from our credit, NASA National Aeronautics and Space Administration / ESA European Space Agency / ESO Astronomy / Frédéric Courbin, EPFL, and Pierre Maguin, Université de Liège. When Saturn is tilted towards Earth, the planet gives Hubble a magnificent view of its bright icy structure. Hubble made this observation of Saturn on June 20, 2019 as the planet made its closest approach to Earth that year, at approximately 1.36 billion kilometers away. Learn more about Saturn and Hubble's observations from our credit, NASA National Aeronautics and Space Administration / ESA European Space Agency / A. Simon, NASA's Goddard Space Flight Center, and M.H. Wang, UC Berkeley. What does the aftermath of a cosmic cataclysm look like? Our latest picture of the week shows the tattered remnant of a supernova, a titanic explosion marking the end of the life of a dying star. This object, known as DEM L249, is thought to have been created by a Type 1a supernova during the death throes of a white dwarf. Read more. Image credit, ESA European Space Agency / Hubble Space Telescope / NASA National Aeronautics and Space Administration, Y. Chu. A global citizen science project found over 1,700 asteroid trails in Hubble images. Combining artificial intelligence with many keen human eyes, astronomers have found the asteroid trails in 37,000 archival Hubble images that span 2 decades. Full story details the mosaic in the image consists of 16 different data sets from the NASA / ESA Hubble Space Telescope that were studied as part of the Asteroid Hunter Citizen Science Project. Each of these datasets was assigned a color based on the time sequence of exposures, such that the blue tones represent the first exposure in which the asteroid was captured and the red tones represent the last. On International Asteroid Day in June 2019, an international group of astronomers launched the Hubble Asteroid Hunter, a citizen science project to identify asteroids in archival Hubble data. The initiative was developed by researchers and engineers at the European Science and Technology Centre, ESTEC, from ESA European Space Agency, the Spanish Centro de Astrobiología, CAB, INTACSIC, and the European Space Astronomy Centre's Science Data Centre, ESDC, in collaboration with the Zooniverse platform, the world's largest and most popular citizen science platform, and at Google. The astronomers collectively identified more than 37,000 composite images taken between April 2002 and March 2021 with Hubble's ACS and WFC3 instruments. With a typical observation time of 30 minutes, asteroid trails appear as curved lines or streaks in these images. The combination of citizen science and AI resulted in a final dataset containing 1701 trails and 1316 Hubble images. Image credit, ESA European Space Agency / Hubble Space Telescope / NASA National Aeronautics and Space Administration, SCRUC, ESA / ESTEC, Hubble Asteroid Hunter Citizen Science Team, and Zamani, ESA / Hubble. If you read our entry about red giant, answer this: Hubble uses red giant stars to calculate them? Distances to different galaxies, mass of the host galaxy, brightness of different galaxies.